Well, thank you. I've got two jobs, I think, today. One is to talk about science, and I'm going to take that opportunity to talk quite a lot about science. I want to talk about some astronomy, some particle physics, and a little bit about graphene. But also my job, because this is a property conference, is to talk about the university and to tell you about where the university is now globally and where it sees itself in a decade, how it sees itself expanding. And therefore, what I hope, I think what Manchester hopes, is that you'll get a sense of where the city may be and the interface, the interaction between the city and the university. So this is the picture of Manchester University that I think most people have, of a grand and extremely successful university in a historical sense. And Manchester, of course, is a city. I thought I'd read just a little paragraph to you. It's written by Stephen Jay Gould, who's a very famous biologist, and he's commenting on some comments by a famous physicist called Freeman Dyson. Freeman Dyson wrote one of the great essays that's been written in the last 50 years, I think, about human progress, and it's called Manchester and Athens, because Dyson's contention is that the two most important cities in the world are Athens and Manchester. I think he's right. And this is what Stephen Jay Gould had to say about why he agrees that Dyson's right. He says, Manchester, to Dyson, is the embodiment of a theme that encapsulates the very best in natural beauty, universal ethics, and human effectiveness. Diversity. In Manchester and Athens, the finest essay that Dyson has ever written, he compares the Athenian search for timeless general laws of nature at the highest level of abstraction with the gutsy, hands-on practicality of those who made the Industrial Revolution and their supporting scientists and engineers who rolled up their sleeves and worried how this would work in that situation before they tried to comprehend the universe. Dyson extends this contrast to two basic styles of science: theorists and quantifiers who continue the search for unity and simplification, and the putters and historians charged with explaining the inordinately complex particulars that never occur twice in nature's intricacy. He calls them the Manchesterians. I think it should be the Mancunians, in fact. But he says, in an apostasy most welcomed by this reviewer, Dyson, though trained in the central corridor of Athens, casts his lot with the honest toil of northern England. I think it's a beautiful essay, actually. I recommend it. The point is that if you look at the history of science, Manchester's clearly central, not only the Industrial Revolution, but if you look at this building, just off the bottom right-hand corner, there's a place where Rutherford discovered the atomic nucleus. The first computer to store a program was invented in Manchester. We all know these things. But what's interesting is that if you look at the rate of success in science and innovation in Manchester, it's pretty constant. I mean, certainly in terms of Nobel Prizes, Manchester today has 4 Nobel Prize winners on its staff, which is more than any other university in Britain. The figures, which I think are worth pointing out if you're thinking of what the potential for Manchester as a city university is, are quite astounding. 40,000 students makes it the biggest university in Britain, 10,500 staff, of which over half are research staff. So academics, researchers and technicians, a turnover of £800 million. And then if you look at the new university and you ask how did we get to that, then you can really trace it back to the visionary merger between the two previous universities, Victoria University and UMIST. That happened in 2003. I've been there, by the way, since 1992. So I'm in my 21st year at the university. And I saw it absolutely transformed by this merger. I mean, when I got there, then the university was successful, yes, but it was 83rd in the world by in research rankings. So it was a reasonable university, but not probably a world-class one. Since 2004, there's been $750 million in capital investment in the university. You're looking at one of the great lecture theatres University Place there, which can seat up to 850 students. I lecture in that lecture theatre in the autumn term. 870,000 square metres of managed estates the university's got now, a tremendous estate. 9,000 student bedrooms to house those 40,000 students. And most important, I think, for the future, there's a 1 billion estates plan, investment in new estate over the next 10 years. The strategic investment we've already made has been, just recently actually, we've appointed 120 world-leading scholars across the university to try and transform the university's position. And as I said, what that's done is raise the university up to number 40 in the world from number 83 in the world. And our plan, our vision, I'm just going to show you this picture actually before I say that. This is the inside of that lecture theatre. It's a spectacular place to lecture. I lecture first-year undergraduates in this lecture theatre, but we can put on vast public events. As a conference venue, it's an extremely successful place, actually. But the plan, as I said, is to go into the top 25 by 2020. So we've already gone from 83rd to 40 with that capital investment programme, the recruitment of academics and researchers. Our goal is to go into the top 25 by 2020. How are we going to do that? Well, the university has a very clear plan, and that's what I want to really focus on. Its plan is based on three foundations. Number one is world-class research. Number two is outstanding learning and student experience, so the teaching quality in the university. As I said, we're the biggest university in the country in terms of the number of students we teach. And social responsibility. And I think this is probably the area that meshes best into the city. See, the way that I see, this is a kind of personal vision, if you like, of what I think a university should be. I think Manchester's a unique place because Manchester has got this enormous university. It's the UK's second biggest city. If you look at our competitors in the UK, you've got really 4 other universities. Certainly in England, you've got Oxford and Cambridge, and you've got Imperial College and UCL in London. By all measures, those are our competitor institutions. You look at Oxford and Cambridge, the university dominates the city. If you look at London, then you've got a very big city with Imperial and UCL sat in it. What I see as the opportunity for Manchester is a rather more equal partnership. Neither the university nor the city size itself dominates. And what I'd like to see, and what the architecture actually of the university, of the expansion of the university has tried to make possible or to encourage, is that a university, I see it as a place of an engine of change, if you like. What you've got here is a world-class think tank. You've got Nobel Prize winners, world-class scientists and students, 10,000 international students in and around the university living in the city. I think that what the university can be is an open, outward-facing institution that can change the way that the people of the city think about knowledge. It gives them access to knowledge. You see it in the architecture. This is the A.V. Hill building, which is the centre of the university's biotechnology corridor. It's linked to the teaching hospitals, to a big Wellcome Trust biomedical research facility. It's linked and it faces outwards. It's not an inward-facing building. All the new buildings face outward into the community. And that's because the goal of the university is to welcome the people of the city in. So you'll see the changes that have been made on Oxford Road, the proposed changes there to bring the city centre into the university. I think this is vitally important, and I think it's unique for Manchester. And what it should be is a blueprint for the rest of the country. I mean, I and many other people passionately believe that the future of the UK economy is in the knowledge-intensive services and industry. It's already over 40% of UK GVA or GDP. It's got to be more than that. The way to do it is to inspire and educate the population, and the way to do that is to use these enormous resources. And I think that's one of the places that Manchester is absolutely unique. Well, Manchester is a unique place to do that because of the relative size of the university in the city and the geographical spread of the university, which if you look at a campus map, weaves its way in and out of the city centre. It's right in there. And I think we've got a tremendous challenge and opportunity to invite people in to just learn about ideas, to be what a university is in the real sense. It is a university. It's about universal learning. It's about exploring nature. And I think that's what the architecture and the future vision of the university absolutely is. And that's why that social responsibility pillar is, and I know that Dame Nancy Rothwell and everybody else in senior management at the university see it as an equal pillar with the rest of it. Social responsibility, outstanding student experience, and world-class research. So that's the inside of the AV Hill building, by the way. So let me talk about some of that research, because I think it's fun, basically. So this is the Jodrell Bank Radio Telescope. I just want to put one more set of figures on before I talk about that. This is to show how successful we are at the moment. As I said, we're on this trajectory to get into the top 20 or 25 universities in the world by 2020. We're absolutely on that road. You look at teaching and learning. I've talked about social responsibility, teaching and learning. Look at physics, which is my department. This is a little table which is of the applications, the intake, and the A-level averages from 2008 to 2012. So you think what's happened in physics is that our application numbers have gone up from around 3,600 in 2008 to 5,500 in 2012. We're now taking 260 students a year with an A-level average of A-star AA, actually higher than A-star AA, which makes us the highest grade requirement in the country for physics. Our goal now is to recruit more academics so we can increase that number. The reason we don't increase that number is because we want the staff-student ratio to stay appropriate. We want to be able to give tutorials to those students. At the moment, we have physics tutorials where we have 1 student to 4 staff. So to maintain the teaching quality, we need to appoint more academics, and that's what the university's plan is. But this is a tremendous success story. It's harder to get into Manchester to do physics than it is to get into Oxford or Cambridge to do physics, which shows about the high regard in which the university is held. And I should just say globally in the university, because there are astonishing numbers, 52,000 undergraduate applications in 2012 for our university places, and it's the most targeted university in the country by the top 100 graduate employers. So it's undoubtedly, as well as being the biggest, it is arguably the highest quality teaching university in the country. Now you can argue about bits and bobs of the figures, but certainly in certain areas it is that. So what about the research? Well, the Lovell Telescope at Jodrell Bank, absolutely iconic, and still doing frontline research. But the most exciting thing, I think, in radio astronomy over the next half a century is going to be a new project which is actually physically based in the Southern Hemisphere, but the management of the project is based at Jodrell Bank. So another of our new buildings, this is an impression of it. I think it's virtually built now, this building, isn't it, as far as I know. It's on the way to being built, but this is what it should look like. It's the project centre for something called the Square Kilometre Array. It's a remarkable project. This is an artist's impression of what that thing is going to look like. This is the South African bit of it. So it's a radio telescope array based in South Africa and Australia. The total surface area of the dishes is going to be a square kilometre, which is why it's called the SKA. It's dotted over these vast wasteland areas north of Cape Town and north of Perth in Western Australia. That's because there's very little interference in those places, radio interference. This is another picture of part of the project. These are the lower frequency radio telescopes. And its job is to survey the sky in absolutely unprecedented detail. One of the remarkable things it's going to be able to do is it's going to be able to look into black holes, and in particular look at black holes with objects called pulsars orbiting around them. Now, pulsars have been studied at Jodrell Bank for many, many years. They're stars with the mass of the sun collapsed to the size of a city like Manchester that spin around, some of them many thousands of times a second, and they're incredibly accurate clocks. They're as accurate as atomic clocks. And what the SKA is going to be able to do is look at those clocks orbiting around black holes and see that the way that space and time are mixed up and bent and warped around black holes, and provide precision tests of Einstein's theory of relativity, of Einstein's theory of gravity. He's going to test that theory, which has been around since 1915, with an unprecedented precision. It's also, not surprisingly, going to be the most sensitive instrument probably on Earth to look for signs of life beyond Earth. So that's a picture of an amino acid. Amino acids are the building blocks of life on Earth. They have a particular signature in the radio part of the spectrum. And so powerful is the SKA that it's going to be able to look for the signatures of biological molecules around other stars and in the atmospheres of planets and drifting through nebulae around other star systems. So we might find life beyond Earth on a distant star system before we discover it beyond Earth in our solar system because of the instrument, because of the SKA.